for the tasks to complete for Unit 1, Lesson 8. This is U1L8. You can either go to the campus homepage, go to that calendar, weekly calendar, or look under assignments. There's a list of what we'll be doing today. First, I just wanted to check in about the homework. Please make sure you have submitted photos of your notes about the sun presentation and the inner planets Mercury and Venus presentations that we saw the last time we met. Please make sure you filled out that feedback survey. I really appreciate honest feedback. I'll be looking at that over the weekend and making adjustments accordingly. And if you haven't done so, make sure you've posted a link to your presentation on the discussion board. And if you did present already, so group 1 and group 2, make sure you've submitted your questions. Anything you want to review or look over on that in terms of the homework, or anything anyone needed help on? All right. Well, then we're going to use a little Kahoot to see what you remember from that very first presentation. I found kind of a little 10-question simple Kahoot all about the sun. Some questions were covered in the presentation, some weren't. Let's just see how we do. I'm going to share my screen and we'll play this. I assume you've all probably used Kahoot before. All right, here we go. All right, so again, you can go to kahoot.it and enter that game pin, 9191023. That's like a super long game pin. Or if you have the Kahoot app on your phone, and yeah, I appreciate you just using your normal name, please. Okay, we got 14 people in attendance. We're up to 11. Here we go. Oh, Moneybags Bryce. All right, we're waiting on one person. I think I'm gonna go ahead and start since we have most people signed up. Whoever we're missing, the code, the game code is always on the lower part of the screen if you just look there. So here we go. The sun is the center of. The sun is the center of the solar system. Very good. Some of you went with the galaxy. That is not the case. It is a good question about what exactly is at the center of our galaxy, technically. Definitely not the universe, so that is the way some people used to think. All right, Danielle in the lead with Eric close behind. The sun represents what percent of the solar system's mass? Very good. It is indeed 99.8%. That's straight out of the Hewitt reading. Somebody went with 75%. Not quite. It is pretty mind-boggling to think how much that is, though. Danielle is still in the lead with Kayla catching up now. What is the reaction pictured below? This wasn't necessarily covered in the presentation, but see if you can guess. Very good. Most of you got it. It is nuclear fusion. It's where all that pressure that was mentioned at the center of the star forces hydrogen atoms together to make helium. All right. Eric in the lead now with Brandon close behind. The sun's diameter is roughly how many times the size of Earth's diameter? Again, take your best guess. I'm not sure. only 2 people got it. It is actually 100 times. Most of you only 10,000 times. It is kind of surprising. You would think that it would be much more, but it is indeed 100 times. All right, Eric's on fire in the lead with Brandon close behind. Halfway. The sun's mass is blank times that of Earth's mass. So very similar question, but mass this time instead of diameter. Very good. Oh, again, only 2 people got this. It is 1,300,000 times more mass. So that's kind of the mind-boggling thing, that it's not necessarily the size that is the dramatic difference. It's only 100 times wider, but it is over 1,000,000 times more massive. So it's sort of, I guess, a density and size thing. All right. Ronan now in the lead with Eric close behind. This is a close one. Which portion of the sun is closest to the Earth? We talked about layers of the sun. Which layer or portion of the sun is closest to the Earth? Very good. Quite a few of you got this. It is indeed the corona, outermost part. And again, a word that we will always associate with negative things from this point forward. All right, Eric in the lead, Ronan close behind. These guys are vying for first. Which state of matter requires the highest temperature? Wow. All right, 5 of you got it. It is indeed plasma. Plasma is one state beyond gas. It's sort of like an electrically charged gas almost. A lot of you went with gas, but plasma is the next level up. All right, Ronan pulled in the lead again with Noah close behind. The sun uses blank to produce prodigious amounts of energy. Kind of a repeat question, if that helps you. Very good. Repeat question, sort of nuclear fusion, again, is that source of energy. So think of electric cars as running off of the sun. All right, Brandon in the lead. True or false? The sun produces a magnetic field. Very good. Most of you got that. That is true. That's why we see tails on comets, and also why we get the aurora borealis, and also I forget the name of the one in the southern hemisphere, but all those lights are a result of the magnetic sphere. Okay, Brandon is holding the lead. This is the last question. Here we go. The solar wind it's kind of a hard one. Take your best guess. Yeah, most of you got it. It is a stream of electrically charged particles. And again, I can see a lot of you got thrown off by nuclear fission. Again, remember, it is fusion that's happening in the sun, not fission. Here we go. Ready to go, Brandon. All right, Eric. Who won? Hey, nicely done, Noah. All right, let me close this down so all this loud music stops. All right, good job, everybody. Once again, thank your sun presenters as well for helping us through that. So, okay. Then without further ado, we will hear from topic number 3 and topic number 4 today, which starting us off is going to be Eric and Lena talking about Earth and Mars, the last of the 2 inner planets. And then we'll hear from Brandon and Noah about outer planets. Eric, Lena, Brandon, Noah, you're all feeling ready today? Yes? Okay. We're going to start off with Eric and Lena. So what I need everybody to do, Same expectations as last time. I would like you to take notes. You're going to need to take a picture of your notes and submit them as an assignment. So whip out a notebook or piece of paper. The title you need to give your notes is Inner Planets, Earth and Mars, from Eric and Lena. Eric and Lena, how do you want to do this? Do you want me to open the presentation and just go through it as you talk, or does one of you want to do it?
I can do it.
Want to do it? Okay. So Eric, I'm going to make you a co-host so you can share your screen. And then take as much time as you need to make sure you're ready, get things loaded and up. If you have any videos, it might be good to preload those. And then we're ready to go whenever you are.
So share screen, Chrome, share, and present review. So everyone can see my screen of the.
Yep. Mm-hmm.
Okay, right. So yeah, today we are talking about Earth, Mars, and how human might get to Mars. Very interesting topic in my opinion. So
Lena, you feeling ready?
Yep.
All right, let's do it.
Yeah. So let's just start with Miss Lena trying to get us through the vocabs here. We have like quite a few like hard vocabs for today. So first of all,
the habitable zone. The definition of the habitable zone is the orbital region around a star in which an Earth-like planet can possess liquid water on its surface and possibly support life. They're also called the Goldilocks ring because of the fairy tale of the three bears in the forest. And they're used to describe the distance that is not too far or not too near.
Yeah, right. Like, in case anyone hears like the Goldilocks, like the girl goes into like the forest, meets like goes into a hut, and they're like something happens, a lot of things happen, and
well, the porridge is either not too hot or not too cold, right? That's
yeah, like the porridge, the bed is either not too soft and not too hard, and in this case, the distance is like neither too far nor too near. So, which is, and you can see like on this picture that there are like three little planets that are basically fitting the Goldilocks zone, which is Venus, Earth, and Mars. And that's why, like, these are like the three inner planets for the terrestrials, like the terrestrial planets that are having like this most attention in our solar system, because like, yeah, you see like they do have possibilities of presenting life. And now we move on to the next one.
So you can see the sun in the middle and Mercury, Venus, Earth, and Mars. Earth resides on the just right from 150 million kilometers from the sun. Therefore, water can exist predominantly in liquid phase on Earth. And Mars resides on the outer fringe of the inner planets, and therefore it's a bit colder. So it has polar cap composed of mixture of water and ice and carbon dioxide, dry ice.
Okay, now we move on to the third one, the carbon dioxide cycle.
The definition of the carbon dioxide cycle is a type of regulation of the Earth that acts as a thermostat to keep global temperatures from reaching harsh extremes by controlling the temperature through adding and removing carbon dioxide in the atmosphere. So, for example, you see these dead organisms and waste products, fossil fuels, and auto and factory emissions. They all result in carbon dioxide, and so if the Earth became frozen, that would melt the frozen Earth because it would warm the atmosphere. And if the Earth got increasingly hot, then the ocean, more water would evaporate. Oh, sorry, I can't see that. More water would evaporate and it would lead to more precipitation, which would remove or reduce the carbon dioxide from the atmosphere. And so the greenhouse effect would be minimized and the Earth would cool down.
Nice. You make a good point about how CO2 is really good at capturing heat. We need that, right, to survive. We hear all this bad stuff about CO2 rising and global warming, and yes, we should be concerned, but it's not like we need to eradicate CO2 or else we go into a total ice age. You all calculated your contributions to this when we did that carbon footprint calculator, how much CO2 you produce. So, great.
Yeah, exactly. So also like I want to ask like this question of like is carbon dioxide cycle the same as carbon cycle? Because when we search like on the internet like the carbon dioxide cycle, there's a lot about carbon cycle, which I know like
Yeah,
one dioxide does make some difference.
yeah. What you're seeing, the picture you have here is the carbon cycle. It's just that carbon dioxide is probably the most abundant form in its gaseous form, but once it's
Right.
down in the earth or in organisms, it's in other forms.
Yeah, like rocks in the rocks here.
Yeah, and sugars and stuff like that.
Yeah.
Yeah.
Okay, now we come to the magnetosphere, which like the solar wind question, we do cover it here because the region in the atmosphere where magnetic phenomena and high atmospheric conductivity caused by ionization are important in determining behavior of charged particles. So you see like here we have the solar wind coming. The solar wind is like it's technically not a wind. It's like a ton of like charged electron like just coming to Earth. And if not for the magnetosphere, like the atmosphere will be stripped away, like and then there will be and the ultraviolet rays will just literally burn you alive. And basically like that. You see, actually, magnetosphere is very important. And what causes magnetosphere there? Because like Earth has like this molten core that is abundant with iron, and it basically makes Earth like this huge magnet in this, like in the solar system. And because like all magnet has like this that's magnetic field. The magnetosphere is basically caused by the Earth's magnetic field. And interestingly, the magnetosphere of the Earth actually they like the Earth is like a magnet that it has like this north pole and south pole kind of thing. Also, like it reverses like in the Earth's forming history because I don't know like something happens and actually when you see like when you observe rock and how like the iron in the rock react, you can actually show that the Earth has reversed several times like in its magnetic field.
Hmm.
Right. So we move on to the next one, which is the Earth itself. So I'm going to introduce a little bit about the Earth. I know we know a ton about the Earth already. The revolution is interestingly 365.25 days, which makes sense because every 4 years you have 1 day with plus 1 day like 336. It's just for easier calculation. Rotation period 23 hours, 56 minutes, and 4 seconds. That 56, that like actually 3 minutes and 56 seconds were just easier for like us to calculate. Mass, like doubtlessly Earth has a ton of mass, like this 10 to the 24th power kilogram times that thing. And well, it seems a lot, but it's actually not that much like, solar wise, because considering like the sun is that 13,000,000,000 like much times like the mass of Earth, and the sun is even not even not even anywhere close to large in the scale of like the universe. And so water covers 60%, like 70% of the universe, like 70% of the surface of the Earth. So Earth is technically not Earth, but not Earth. Like it's because Earth is basically like this terrestrial kind of concept, like this terrestrial kind of conception, but Earth is actually not. Atmosphere, very important. That's 78% nitrogen, which is interesting because there isn't actually a lot of oxygen out there. Well, we think that oxygen is like mostly important. 21% oxygen, and also like just pure oxygen would be like deadly to all like living creature. 0.97% argon and carbon dioxide, and 0.04% trace, like other amounts of the gases. There are some gases out there. Why does Earth stand out? Like, why do we talk about Earth? Well, if there hadn't been Earth, this lecture will not happen. I mean, this course will not happen. Like the school will not be founded, and California will not be like there will be no California. Like there's basically nothing without Earth because we live on Earth. So now the larger bulk of our lecture, Mars.
So I'm going to be talking about the red planet. So the revolution is 687 days. The rotation period is 24.6 hours. Mass 6.39.10 square 23 kilograms. The radius is 3,389.5 kilometers. The two Martian moons are Phobos and Deimos. You can see the bigger one that's closer to Mars is Phobos, and the smaller one is Deimos. And the atmosphere contains 1% water vapor, 95% carbon dioxide, 3% nitrogen, 1.6% argon, and it has traces of oxygen. Of course, these elements we cannot breathe without an oxygen tank, so Mars is pretty inhabitable, but it is the second most habitable planet besides Earth. And that is because Mars has seasons, and they're twice as long as Earth's, and they have polar ice caps, and they're also drinkable, volcanoes, canyons, and weather. And the reason why the seasons are 2 times longer is because it takes 2 years for Mars to orbit the sun.
Right. So now we have this, which is like...
So here is a deeper explanation of the Martian moon. Asaph Hall was a scientist that discovered the moons after difficult research in August 1877. They're among the smaller moons in the solar system, and Phobos whips around Mars 3 times a day. Deimos takes about 30 hours for them to orbit Mars, and the distance between Phobos is 6,000 kilometers, Deimos 23,460 kilometers.
All right. So why are we talking about Mars? Like, why is like all scientists fussing so much about Mars though? Because Mars is actually once quite capable of hosting like ecosystems. It might still be like for like microbes. You see like the microbes. But then still, like, why Mars? Even if Mars is like habitable, what does it matter? We have Earth. Like, we have this good old Earth going around here for like billions of years. Why do we have to care about Mars? It has something to do with like crazy rich people that does not hold much confidence in Earth. Human society will get destroyed in 2000 and like in the 22nd century, something like that. And interstellar industries are making a ton of profit. Monsieur Elon Musk will be referring to him shortly later. And what happened if astronauts stand on Mars? Like, there's no right answer about it because no astronauts have stood on Mars before. That has never happened. Like, human mission to Mars was a thing in the Cold War when President Ronald Reagan tried to launch the Star Wars activity, like the Star Wars program, which is to send like manned mission to Mars. After hearing that it will cost like several $100 billion per year, will have to last for like 20 years or so and cause all the death of the astronauts because spacesuit was not good enough. The plan was dropped. Though, like, no one has gone to Mars before, we can infer what happened on Mars since Mars has a pretty Earth-like activities compared to other planets in the solar system. But wait, right? That like the Mars mission and satellites, and they're like landing sites going on. Like there are non-human like spacecraft mission to Mars, and here's basically where it is.
They're basic rovers. Eric, if you go to the previous slide. This website on the top, I highly encourage you guys to read through it because there's a list of the rovers that's on Mars. And there are 2,666 satellites currently orbiting Earth. And there are up to 14 artificial satellites in the Mars's orbit, but 6 of which are active. And yeah, if you go to the other slides. This is basically just the diagram of Mars and the tie-in when one is another rover led by the Chinese Chinese astronaut kind of organization, you could say. And you can just see the diagram, like the labels and things.
Okay, so yeah, here's someone who actually lived on Mars, and let's just see it. It's a short one.
I guarantee you that at some point Everything's gonna go south on you.
Ready?
You're gonna say, this is it. This is how I end.
Commander, Mark is dead. We both go.
Now you can either accept that, or you can get to work. This will come as quite a shock to my crewmates, and to NASA, and to the entire world. But I'm still alive. Surprise. Here's the rub. It's gonna be 4 years for another mission to reach me. And I'm gonna have to...
Okay, so nope. Basically, we see like this big this big Martian storm coming up, very scary, like destroy the land base. They have to like go without this Martian guy, but is it possible like someone will be like blown away in like this huge blizzard on Mars? Not likely, because although Mars, like they do have very large wind. They do have like, actually the wind on Mars is 8 times more like ferocious on Earth. Can't even actually do much of the like damage in like the half of the damage, or even like a slight bit of the damage on like the movie show, because Mars doesn't have like this thick atmosphere. Why? Because Mars is like a lot smaller than Earth. It's like more than half of the size of Earth, but it has like this much smaller core that will cool off like much quicker than Earth core is. So Mars did have like this once suitable for life kind of environment going on, but like as its core cooled off, the magnetic field we mentioned earlier, like it disappears, because like one cooled iron core doesn't make much of a use as a magnet. So solar wind, as we mentioned, they torn up Mars, like most of the Martian atmosphere, and so there's no like carbon dioxide, this kind of cycle going on. So water cannot form, temperature drops, water freezes, boom, end of game. And because of like the Mars is such like a thin atmosphere, wind will actually not do much of a damage. Wind will like merely affect someone on Mars. So yeah, that's something that's not actually true. So the most important part of this lecture today, will Elon Musk get us to Mars? Oh, students say this. Right. Yeah, so SpaceX is having like a lot to do. I actually log onto the SpaceX, like the very fancy website, very promising pages, actually shown like the spacecraft going around to different planets. But we still have a long way of going to Mars. Think about like the Apollo mission to the moon. The moon is like it's 238,009 miles away from Earth. Well, Mars is like 17 times farther. So it has like to do a lot with like Apollo mission, but like beyond that, Mars is more than 17 times difficult. Like you cannot just calculate the difficulty like times the distance. It's a lot more difficult. Like all the fuels, think like how will like the spacecraft go to Mars, like with all the like the fuels coming up, like he has to cut. And also like even if we reach Mars, like what we do, like it takes basically a ton of time to go to Mars. And even if we do go to Mars, like we can't actually do like this systematic approach to trying to let us to go to Mars. So I would say probably like a long way. Like SpaceX want to build like this city on Mars, and it says that it will come at 2024, but well, we are still hoping, Mr. Musk, so get going. And that's basically it. Yep.
Well, he did. Yeah.
Right, thank you very much.
Awesome. All right, thank you. Have everyone unmute yourselves, please. Quick round of applause from all over the world. All right. Any questions for our experts on Mars or Earth? Looks like you did such a good job. You answered everyone's questions. How many people have seen The Martian? with Matt Damon? Most of you. Okay, now here's the next question. How many of you have read the book, The Martian by Andy Weir? Oh, two of you? A little bit? Oh, anyway, go check out the book if you enjoyed the movie. But Eric, you made a great point about the thin atmosphere and the lack of a magnetosphere. That was really good. And Lena, your website about the missions to Mars, the sites and everything in the satellites, that's really fascinating. Something I hadn't thought about before. So good job there. To me, what always comes away, what I came away from when learning about this is just how lucky we got being on Earth. The fact that there was this huge molten core of metal, there was enough water, we're in what's called the Goldilocks zone. It just seems pretty nuts that all these things came together, but theoretically could also happen in other solar systems. So, all right, if there's no other questions or comments, then let's go on to topic number 4. Brandon and Noah, feeling ready?
Yeah.
Okay, this is going to be the outer planets. So we've made it through our first 4 inner planets. Now it's the outer planets. So everyone should be titling their next notes "The Outer Planets" by Brandon and Noah. Brandon and Noah, how do you want to do this? Want me to open it, or does one of you want to do it?
I think you can just open it.
For me?
Yeah.
Okay, let me pull it up on the discussion board here. I assume it got posted, right, at some point. I see it. Okay, let's see if I have permission. Alrighty. So just tell me next slide or whatever else you need to. Once it's finished loading, I'll hit present.
All right,
Whenever you
so
are.
Outer Planets by Brennan and Noah. Introduction. The outer planets, a planet whose orbit lies outside the asteroid belt, for example, Jupiter, Saturn, Uranus, and Neptune. Characteristics about the outer planets. Jupiter, Saturn, Uranus, and Neptune are large gas giants with rings around them. These gas giants are mostly made of hydrogen and helium. These are the same elements that make up most of the sun as well. Location. These are the 4 planets farthest from the sun. The outer planets are much larger than the inner planets. And moons and ring patterns. All of the outer planets have numerous moons. They also have planetary rings made of dust and other small particles, but only rings of Saturn can be easily seen from Earth.
Jupiter is the largest planet in our solar system. It has a radius of 22.71 billion miles squared. Jupiter is so big that 1,300 Earths could fit inside of Jupiter. The planet's days last 10 hours. It takes Jupiter 12 years to orbit our sun, and it has 79 moons. Jupiter is made of 90% hydrogen and 10% helium. Jupiter's gravitational pull is actually 14 times greater than our own planet. Jupiter is the 5th farthest planet from the sun. It has winds up to 500 miles per hour.
Supposedly that that little eye there, right? That little storm is
Yeah.
like several times larger than Earth itself, and it's literally like a horrible storm. Crazy to think.
Jupiter is made out of mostly hydrogen and helium. So if you tried landing on Jupiter, it'd be like landing on a cloud. Jupiter's like atmosphere also has no oxygen, so you'd have to use a suit with like an oxygen tank. On top of that, it has scorching hot temperatures and 300-mile-per-hour winds. The winds in Jupiter are caused by Jupiter's rotation. It's actually the fastest rotating planet in the whole, like our whole solar system. And yeah, next slide. Saturn is the 2nd largest planet in our solar system. It has a radius of 16.49 billion miles squared. A total of 700 Earths could fit inside of Saturn. Saturn's days are half of Earth's, lasting around 10 hours and 45 minutes. The planet takes a total of 29 years to orbit our sun and has 62 moons. Saturn is made out of mainly hydrogen and helium, just like Jupiter. And Saturn has the lowest density for a planet in our whole solar system. It actually has the fastest winds. It has its winds in its outer atmosphere reach up to 1,200 miles per hour. Next slide.
Oh, sorry. So going. Yeah.
I was actually able to do a bit more research on what would happen if you fell into Saturn. So I actually found a whole video on it on YouTube. So if you tried walking in Saturn, it'd be like suicide. You'd plummet, just like Jupiter, you'd plummet through clouds, and you'd fall around. You'd be falling at about 1,000 miles an hour because of Jupiter's gravity, or because Saturn's gravity is much stronger than our Earth's. And once you went through like the upper atmosphere, you'd go into like a dark zone filled out like clouds made out of ammonia crystals and frozen water, and the winds down there could reach up to 1,200 miles per hour. Next, we'd reach clouds made out of ice, and the pressure would be 10 times greater than our own atmosphere. After around 2 hours of falling, you'll have traveled about 250 miles, and the atmosphere around you will begin to heat up, and it'll reach around 100 degrees Celsius. Slowly, after about 3 weeks, you'll reach the core of Saturn, and the density, it's thousands of times, it's the atmosphere around it is thousands of times greater than our own on Earth, and you're going to be stuck in liquid hydrogen and helium.
Yeah, not a pleasant experience.
Yeah.
Oops. There you
go. Uranus. Uranus is 3.121 billion miles squared, and 17 hours for one rotation, and 84 years around the rotation of the sun. It has 27 moons, and its atmosphere is made of water, methane, and ammonia fluids above a small rocky center. And that's its conditions on. And then the hydrogen and helium are its atmosphere's makeup. And Voyager 2 flew past Uranus in 1986. And Voyager 2 was giving us our first up-close view of the planet. It is still functioning today as it flies deep in space more than 10 billion miles away from Earth. Voyager 2 and its companion spacecraft Voyager 1 are returning data on how the influence of our sun wanes as they get further from it, and on the characteristics of space between the stars. Next slide. Uranus continued. Uranus is ice and gas, and if you tried to land on Uranus, you would just sink through the upper atmosphere of hydrogen and helium into the icy center and plummet to your death. And that is a picture of Voyager 2 on the left-hand side, and then the makeup of, I don't know why there's Neptune. I'm sorry about that one. That is not the right picture. Neptune is 2.941 billion miles squared. 16 hours for one rotation and 165 years rotating the sun. And it has 14 moons, and it is made of hot, dense fluid of icy materials and water, methane, and ammonia. Hydrogen, helium, and methane are its atmospheric makeup as well. Talking about the atmosphere as well, these components, specifically methane, are what give the planet its blue color. This is because methane's gaseous composition absorbs red light and reflects blue light outward. And, yes, stay on that slide, thank you. You still cannot stand on Neptune, such as all the other gas giants, and Neptune is the coldest planet. At the top of its clouds, temperatures on Neptune can dip down to 51.7 Kelvin or negative 366.6 Fahrenheit. That's almost 3 times the coldest temperature ever recorded here on Earth at 129 degrees Fahrenheit, which means that an unprotected human would be flash freeze in a second. And visiting Neptune, Voyager 2's amazing photographs of Neptune might be all we get for decades, as there are no firm plans to return to Neptune's system. However, a possible flagship mission has been envisioned by NASA to take place sometime during the late 2020s or early 2030s. For example, in 2003, NASA announced a tentative plan to send a new mission to Neptune called Neptune's Orbiter. And that's all.
Nice. All right. Can I have everyone unmute yourselves? Round of applause. Well done, good sirs. Any questions for these gentlemen on the outer planets?
Yes, I do have one for Uranus.
Uh-huh.
Is it true that it rains diamond on Uranus?
Say again?
Is it true like the Uranus rains diamonds?
I'm unsure about that, but I think because of the cold temperatures and possibly the atmospheric pressure, there could be enough pressure between all of the molecules and gas particles to compress something like diamond. So,
Yeah, that'd be kind of crazy. I don't know if you noticed in the images. So I think it's mind-blowing that all of the outer planets have rings, right? We only ever think of Saturn having rings. Anyone notice what was weird about the rings on Uranus?
This like this. It's
Yeah.
like tilted.
The whole planet's tilted on its side. It's the only one that, and I think it rotates that way too, which is really, really weird. So, yeah, I hear Uranus is like there's so much gas. It's just full of gas, Uranus. And what do you think Uranus smells like? Probably smells pretty bad. All right. The other thing too is getting out to Neptune. Yeah, I think scientists got really excited when they saw that blue color. And were like, oh man, it might be another water planet. But yes, it ended up just being methane. Good detail on how that reflects back the blue light. And as far as I understand, it's weird to think, but if you were on a planet like Neptune that far away from the sun, our sun would just look like another star. Like you wouldn't even be able to identify our sun from all the other ones out there. Like that's how far away you are at that point in terms of perspective, which to me is always kind of crazy to think. So, any other questions or comments? All right, good job. Thank you very much to those groups that presented. Everyone else, please make sure that you have gotten notes and submit photo of those notes to the assignments. Okay, next up. So on the task to complete list, you'll see that I've got a comment about grades and assignments. This coming weekend, we're not reporting grades necessarily, but we are writing comments for any students who might seem to be struggling, missing assignments, that kind of thing in our classes. So I'm still trying to catch up on my grading in most of my classes. I do have quite a bit done in this class in particular. But if you didn't know this already, I'm gonna share my screen here real quick. Go into student view. You can check your grades in this class. If you just go to the Science2 homepage, I'm going to go into student view here, even though it doesn't quite look like what you see even then. But I'm sure many of you already know this, but if you don't, in this little menu bar that is here on the left, where you've got home, announcements, assignments, discussions, there's a grades tab. If you click on grades, it should take you to a page that has a list of all the assignments that I've graded and assigned so far. It'll show you your score. If you scroll all the way to the bottom, it should show you your totals for classwork, labs, tests, participation, and so on, and then give you where your grade currently stands. Now, I don't give zeros. What I do is I give you 50%. So if something's missing, if I don't have it and I don't have it to grade, I give you automatically half the points, but that's it. You have to submit the assignment to get the full points. Now, just because I gave you half a point, just because the grade is entered, doesn't mean you can't submit it. I will accept late work. So as long as you get the work done and into me, I will give it a grade. So let me know if you need an extra copy of something, if you need help with something, I'm here to do that. Homework is going to be at the bottom of the tasks to complete list. Please try to catch up on any missing work you have. Next groups, make sure you're ready to present, which is gonna be, this is A period. So we're gonna be hearing about life on other planets from Tristan and Ronan, and Moon by Grace and Matthew the next time we meet. Grace Kim. What I'm going to do now is I'm going to let everybody go except for a couple students that I need to check in with about missing work. Specifically, can I have Brandon, Bryce, Camille, Daniela, Grace Kirsch, Kayla stay behind. Once again, that's Brandon, Bryce, Camille, Daniela, Grace Kirsch, Kayla to stay behind really quick. Everyone else, you are free to go. Just get your homework done and enjoy the weekend. Thanks.
Thank
Thank
you.
you.
Thank you.